Question number 3. This is a bit of a challenge problem because we deal with multiple right angle triangles and we have to try to find different pieces. So number 3 says, from the top of a 90-foot observation tower, a fire ranger observes one fire due west of the tower at an angle of depression of 5 degrees and another fire due south of the tower at an angle of depression of 2 degrees. How far apart are the fires to the nearest foot? And this diagram is not drawn to scale, so this is our diagram that we're looking at. So we have from a tower, we're looking at 5 degrees angle of depression, which, if you remember, is exactly the same as our angle of inclination. So we're going to put 5 degrees there. And we have 2 degrees here, so that is to the south. We can also put that into this diagram here. This is the one that we're really going to use. And there's a couple other things that we can know about it as well. So we take a look at our diagram here. We have our ranger right on top here. He's looking down, angle of depression of 5 degrees, which means that that angle right there is 85 degrees. This is 2 degrees, so that's 88 degrees. And we want to figure out how far apart are these two. So this is the value that we are looking for. This is our main question mark that we need to find. So how do we find this length right here? Well, let's work backwards here. The only way we can get this length right here is if we know some information about this triangle right here, which I'm just going to shade in very lightly in brown. We need to know some information about this triangle. Either we need to know the side lengths or some angles in the side length or something along those lines. The easiest way will be to find what are these two side lengths. So we're going to call this X, we're going to call this Y, and this is going to be Z. These are going to be the three pieces that we're going to try to solve for. X, Y, and Z. We're going to lowercase because we're going to try to solve for what they are. What's the west distance, the south distance, and then the horizontal distance or the diagonal distance in between them. So we're going to go through a few different calculations in trying to solve that. And the first one, in this case, I'm going to use X, not for any particular reason. You can do X or Y first, but I'm going to solve for X first. And I'm just going to zoom out so we have a little more room to solve for this. Triangle X here, we know that this is 90 feet, and this is going to be our opposite side. I'm going to use the 5 degrees, and we're going to solve for the adjacent side. Opposite, adjacent, we're going to use tan, but I'm just going to put down my information first. Opposite is 90 feet. Adjacent is what we're trying to find is X, and our theta equals question mark. We're going to use tan to solve for it. Opposite over adjacent. And, oh, sorry, I do know the answer here. This is 5 degrees. Don't need to put a question mark in there. It's 5 degrees. So tan of 5 degrees equals the opposite, 90 feet, over the adjacent. If you used 85 degrees, this would then be the adjacent, this would be the opposite. I'm going to show you, I'll do it on this one here, and we're going to get the same answer whichever way we do it, but as long as we make sure to label it correctly. Put that over 1. Our fish method. In the interest of time here, I'm not going to write everything out. I'm just going to give you that X is equal to 90 times 1 divided by tan of 5. And we get an answer of 1,028.7 feet. That's to find X. To solve Y, it's exactly the same thing. I'm going to use a different color pen here so we can differentiate. I'm going to use the 2 degrees again. So this is our adjacent side. This is our opposite in both cases. So to solve for Y, our opposite is still 90 feet because we're using the same side. Our adjacent is what we don't know, so we're going to call it Y, and theta equals 2 degrees. We'll put this all back into the same function of tan, and I'm not going to go through it really quickly, or I'm going to go through it really quickly here so we can get through. Use our fish method again. And sorry, I forgot to put that over 1. There we go. We calculate it out. And so we're going to get Y is equal to 90 times tan of 2 divided by 1. Sorry, I did that incorrectly. It's 90 times 1 divided by tan of 2. There we go. This is the way you're supposed to do it. Please follow that along. I made a mistake on that one. And this is 2,577.3 feet away. We have our X, we have our Y. We said at the beginning what we're going to do is to find Z, we're going to use Pythagorean Theorem to solve for that. So to solve for, we're going to have x squared plus y squared equals z squared. We can do this because we know this is x, y, and z, a, b, and c. You can do it either way. So 1,028.7 feet squared plus 2,577.3 feet squared is equal to z squared. I'm going to calculate this all up together. 1,028.7 squared plus 2,577.3 squared equals, and z squared equals 7,700.6. Oh, there we go. My bad here. 7,700,698.98 is our squared. We're going to take the square root of both of these, and z equals 2,775 feet, and that is how far apart those two fires are. So they had to get in between 2,775 feet.